Now, to figure out the curviness of this function, we need to plot points between these key values. And we can plot whatever we want, though let's focus on pi over 4 radians right between these. And with that, we can also look at 3 pi over 4. We can look at 5 pi over 4. And lastly, we can also look at 7 pi over 4, though I'm running out of room here. And a pi over 4 radian angle is also 45 degrees. And with a pi over 4 radian angle, or 45-degree angle, we can construct a special right triangle on this unit circle, meaning that the hypotenuse is 1, each of these angles are equal, and 45 degrees, or pi over 4 radians. And with the properties of 45, 45, 90 right triangles, we can figure out these side lengths since they are equal, since this is isosceles. And using the Pythagorean theorem and simplifying, we can find that each of these lengths would be the square root of 2 over 2. So when we find the cosine of this angle, which is pi over 4 radians, the cosine is the adjacent divided by the hypotenuse, but the hypotenuse is 1, meaning that this would just be root 2 over 2. And the square root of 2 over 2 is approximately 0.7 if we just round to the 10th place. And we can also look at these angles here. This would be a 135-degree angle, which is right about here on the unit circle, but we would be able to construct that exact same right triangle. It would just be orientated differently, where now the adjacent side is pointing in the negative direction, meaning that our x value here is negative, but it would be the same length. It would just be minus root 2 divided by 2. And same thing for this angle. Pi over 4 is, 5 pi over 4 is right down here. We would get that same right triangle, and the x value there is still negative, but it is still this root 2 over 2. And at 7 pi over 4 radians, now we're back over here. And over here, the x value is once again positive, but it is still this root 2 over 2 size. So at this point, we can plot these different y values given their theta values on this curve to determine the curviness, at least on the right half of the plane. Though what we'll see is that if we look at the negatives for these values, then they would still be the exact same y values. And keep in mind that plotting this by hand is imprecise, especially since we're dealing with irrational numbers. And I also plotted the left half, since we do have symmetry here. When we do the negatives of these angles, we still get the exact values that we got when they were positive. But you can see a general idea of how this curve works. And at this point, let me fill in the actual curvature. Though keep in mind, we can plot more points if we want to get a more exact picture of this. And finally, we can see a rough picture of this curve, though I do encourage you plot this using either a computer or a graphing calculator. But again, what we can see is that this is essentially just a shifted version of the sine function. Let me paste that in one more time. Where this sine function, every point was essentially moved over pi over 2 radians to get this curve right here.